way, I am recording, but the sound is not working. I'm trying to work on it somewhere. I need to figure out the setup here. But here's a formula, but we don't need it. I never use it. I've never memorized it, but people just want that formula. You don't need it. It means average. Middle means average. That's what you did the two tests. How do you find an average? Add them and divide by 2. So exactly what I do. If I have 2 points, you add the x's and divide by 2. It gives you the middle of the x's. You add the y's and divide by 2. This is what it's saying. I take one x, I take another x, add them up, divide by 2. That's where that formula comes from. But just average your x's, average your y's. Okay? So let's do one. If I can get this out of the way. So we're going to find the midpoint of -2, 9, 8, 16. So all I do is I add those x's. I'm going to show a little bit of work just so you're looking over your notes. You're like, where the heck did I get that? Add the x's, divide by 2. Add those, I get 6 divided by 2. 3. Now let's do the same for the y's. Add the y's, divide by 2. Bless you. 9 plus 16. 25 over 2. Now here's a conundrum here. 25 over 2 does not work out nice and neat, right? I could give a decimal or a fraction. If all else fails, I would always give a fraction, because decimals may not terminate. You can't round on your own. So I would always give a fraction, so I would leave that as 25 over 2. Just leave it like that. And on your 84s, I believe they give you improper fractions anyway when you type it in. But if you hit enter and get a decimal, please change to a fraction. You do what, math frac on 84s? It's been a while since I've used an 84. So now let's write our answer the appropriate way. X comma y, 3, 25 halves. Beautiful. We remember midpoints? Now I'm going to give you a similar question, but changing it up. I want to find the value of y if the midpoint of these two is this. So I'm giving you the midpoint. We're kind of working backwards. What did we start with? Well, let's check. I only need to worry about the y, but let's check the x's just to be sure. -6 plus 8 is 2. Divided by 2 is what? That's correct. We're just kind of double checking. So that's what we're going to do for the y's. I know that when I add y plus 5 and I divide by 2, I should get 8. You with me there? And there's no guessing and checking. We're going to show good work. Okay? So here, if you're dividing by 2, I've got to get rid of that first by multiplying both sides by 2. So I get y plus 5. On this side, I get 16. Now to get y by itself, I do the opposite and subtract 5. So I get y equals 11. Told me to find the missing y. And let's check it. If this was 11 plus 5 is 16 divided by 2 is 8. Should be able to plug it in and check. Questions? So don't give me some guess and check. I want to see work on these. Then how about a you try? You try this one. So you're going to work this one on your computer. I'll give you a minute. And then I'm going to scan you. And if you need a calculator, that's fine. I didn't say you couldn't have one. When I'm going to work on board while you're working, don't look up till you're done. not going to affect our problem, but. That should be a 2. Typo. A minute to finish up, and then we'll scan them. Okay, you're gonna hold up A. I could teach it. I got it, 100%. B, I got it, but I made a small mistake. I understand. I just Googled. C's, I generally understand, but I need help. It's a little shaky. And D's, I don't even know what classroom I'm in. I'm that lost. You ready? Hold them up. Back, front. Got them all. All right. So let's go over this. As I said, sorry, it's a typo too. It didn't affect what you did, but then there's a typo. All right, so change some colors here. If I take my 2 points, x plus -2, I add them and divide by 2, that should give me 8, the midpoint. So that's where I got this to begin with. Then to solve it, it's always the same. I need to get rid of that divided by 2, so you do the opposite. You times by 2, both sides. So the 2's cancel. And I went ahead and changed my plus negative to minus, whatever you prefer, it doesn't matter. But the opposite of a -2 is a +2. Do that to both sides and get 18. Questions? Let's review the midpoint. Let's review the Pythagorean theorem. Good old Pythagoras. This is a lifeline. You never get away from the Pythagorean theorem. Every single math class you use, you will use the Pythagorean theorem over and over and over again. In calculus, we use it over and over and over again. It never goes away. It's so handy. It solves sides of right triangles. It's got to be a right triangle, 90 degrees. Okay? Does not work if it's not a right triangle. So we have A, B, and C. What is the Pythagorean theorem about?
A squared plus B squared equals
C squared. But the key thing here is C is the hypotenuse. A and B are legs. That's what we call them if they're sides. Okay, but we remember hypotenuse is directly across from the 90-degree angle, the longest side. C has to be the hypotenuse. This has to be the hypotenuse. Right here. Do you guys know about Pythagoras? That Pythagoras didn't actually create the Pythagorean theorem? Did you know that? You know anything about Pythagoras? They had a cult. No joke. A legit cult. This was in Greek times. Like they had a secret hideout and they come in robes and do math in their cult. No joke. I'm not making this up. They had like a pentagram that they inscribed on their hand and they would hold up secret entrance to get into the cave. They would actually meet in caves, build buildings, and do math. It was a legit cult. But because he was like the cult leader, somebody else discovered the Pythagorean theorem and named it after him. So he gets all the credit, but he didn't actually discover it. So now you know Pythagoras was a cult leader. So every time you do the Pythagorean theorem, you're part of a little cult. Just saying. Let's do one. Let's solve the following triangle. 18, 6, and I could put x here, but I'm going to put C That could be any variable you want. And why did I pick C? Because it's the hypotenuse. So that means these are my legs. It does not matter which one's A, which one's B. So if I do A squared plus B squared equals C squared, I'll get 18 squared plus 6 squared equals C squared. Help me out. What's 18 squared?
24.
No, what's 18 squared? What is it?
324.
324. Okay, I'm here 24. I'm like, oh, right. No more. And then 36 equals C squared. So add those. 360. Okay, now how do you want to do a square? Square root. Now technically you do plus or minus square root. That's backwards. But we don't need the minus. Why? Exactly. It's a length. You can't have a negative length, technically, if you're being correct. Now, here's the thing. If you type in the square root of 360, you're going to get a decimal, correct? We're not going to get decimal answers. We're going to reduce that. Okay? Now, if it worked out nice and neat to a whole number, you're good. But we're going to reduce. Do you remember how to reduce radicals? Did you do trees here? Yes. Okay. That's good. So let's do 360. So name anything that goes into 360.
45.
I heard 36 first. And that's one I tend to do. If I see a zero. But anything works. Anything. You can guess and you can. I always have somebody in here. Do I have two people? Two. So they can no longer do two. I've got somebody in here. You know it. There's always somebody who will do two, no matter what. What goes into 36? 6 and 6. So then I keep going. 2 and 3. 2 and 3. And 10 is 2 and 5. Till I can no longer go further. And you can use a calculator. I'm not testing you on your basic facts. But okay, so remember that pairs go on the outside. So I've got a pair of 2s, which means I'm going to put a 2 on the outside. Come on. I've got a pair of 3s. I'm going to put a 3 on the outside. And then these, they don't have pairs, so they go back inside. And they're always separated by multiplication. So pairs go on the outside, leftovers inside. And I always tell people to remember that. Where do the Thanksgiving leftovers go? In your belly, right? Put them in the belly of the root. Leftovers go in the belly. There's where they go. So 6 squared 10. There we go. And hopefully, if you type in this decimal and you type in this decimal, you get the same decimal. Hopefully. Questions? I said I'm not sure what you guys remember, what you don't, so let me know if like the tree. Let's do another one. How is this different than the last problem? We have C. We have C. We're looking to find a leg. What do you want to call it? A or B? Doesn't matter. B? Okay. So I know that A squared plus B squared equals C squared. And I always write my formula because I'm a good little mathematician. So A is 4 plus B squared. C is 10. Here we go. Okay, so 4 squared is 16. 10 squared is 100. Now I've got to solve for b squared. So you're adding 16, so the opposite is subtract 16. So I get b squared is 84. And how do you want to do a square? Square root. So I get b is the square root of 84. And I don't believe that works out, correct?
Correct.
So we have to tree it. What goes into 84?
6 and 14.
Oh, 6 and 14, I wouldn't have thought that.
4.
4, wait a minute. Yeah, 4 does too, yeah. I would have gone with 4. I saw the 8 and the 4, but that's just me. But, all right, 6 and 14, and that works. So 2 and 3, 2 and 7. So I've got a pair of 2's, means I put a 2 on the outside. Leftovers go back in the belly. Now you multiply. I get b equals 2 square root of 21. And check it for me. Get a decimal for that. Get a decimal for that. Would you do that for me real quick? Make sure we didn't make a little mistake. What if I do a tree and there are no leftovers? It's a perfect square. So we probably didn't need it to begin with. We could have just typed it in and got a perfect square. Okay. What if there were no pairs? Then it'd be already reduced. So if you did a tree, there's no pairs, you're already reduced. Okay. Good stuff. We're good with the Pythagorean theorem? Let's do a little bit of a different one. This throws people because there are square roots in it. Okay, we've got a missing side. What do you want to call it? A, B, or C? A. Don't call it C because we've got the hypotenuse. So I have A squared plus B squared equals C squared. So in our case, I have A squared plus the square root of 12 squared equals the square root of 22 squared. Kind of weird how we have square roots in there. But it works out nice because what happens with the square and square root? They undo each other, right? They reduce. So I'm left with 12. Over here I'm left with 20. Squares and square roots are inverses. They undo each other. They go away. Cool. Now subtract 12. A squared equals 10. Square root both sides. A equals the square root of 10. And you can check it if you want. That's a teeny tiny tree. No pairs, which means it's simplified. But for some reason they see the square roots in there and people start getting confused.
Wait, I have a question.
Yeah.
Why is it simplified?
Because I couldn't get any pairs. The 10
Oh.
and the 10, yeah. So it's already done for me. Questions? You guys are quiet today? Like I said, hopefully it's really boring, right? That's good. When math's boring, it means you understand. It's good. I'll take boring over confused any day. You try. You work this one. Don't look up till you're done. Okay, scan them in. A, I could teach it. B, I got it but made a mistake. C, understand but need help. D is completely lost. Think about this, it's even color coordinated, so I can see right away what you guys chose. Awesome. Everybody got it, not even little mistakes. Sounds good. Sounds good to me. So, homework is day 2. The directions are a little weird. Okay. So, you're going to do these problems right here. But when you get into the 86 to 92, I only want you to do part B. Part A we're doing tomorrow. Distance formula. Okay? Which you may not have seen the distance formula on time. You may not have seen it at all, I'm not sure. But when you get to that, it says part A, do this, part B, do this, you're only doing part B. Okay? So be careful on the directions, you're only doing part B for those. And guess what? We have time. Don't expect this too often. We usually don't have homework time here, but we've got homework time. I'm looking.
Where is the little guy?
Okay, maybe it wasn't a desktop. So you better on desktop.
Oh, hi.
Okay, since we have time though, I haven't graded your homework yet from yesterday, so it was turned in this morning. But did we have any big questions that we want to go over? You're shocked.
Do you think we can go for 2?
Sure can.